Explosion-proof vacuums. They are available in 15-gallon sizes and or 55-gallon sizes. Where you're going to have success selling these vacuums are where combustible dusts are present and or flammable liquids. Some of the applications where you'll have success selling these vacuums are pharmaceutical, food production, flour, starch, sugars. These are all combustible dusts. You can't bring a standard shop vac with a sparking electric motor that does not have continuity maintained through it into that environment. The environment may even be classed and grouped. So a Class 1 Group D atmosphere or a Class 2 Group G and or F atmosphere calls for certain equipment to be used in that environment. Plant managers may not even be aware of the fact that they can mechanize their cleaning with a vacuum like this that we have safely designed for use in that environment. Let's talk about the explosion-proof vacuum and how it's configured. When you're talking about an explosion-proof vacuum, you have to maintain continuity from the tool through the operator handle, through the hose, through the intake, and through the vacuum, through the motor, through the plug, into the wall. You break that continuity anywhere between point A and point B, you're in big trouble. So here's what we have to do. No paper, no down tubes. Pre-filters, you can't have them. Check it out, we've got a steel deflector. Right there. Stainless steel tank. Special intake to maintain grounding, to maintain continuity. Special wheel assembly bracket. Special wheels in the back. Again, what are we doing? Maintaining continuity. Let's start to put the filters in place. This one we're going to set up for wet-dry pickup. If we're going to pick up wet, we have to have a float mechanism. Something that's going to prevent the operator from overfilling the tank. That's what this does right here. Look at this. Steel, all aluminum. This gasket is needed to maintain our vacuum performance, right? Well, this could break continuity. So we actually put grounding straps around there so we don't have that break. That would be put in place. We then have to build the rest of our components. Let's use the one-to-one adapter. Make sure it's seated properly. Clamp it in. We next have to put our cloth filter bag in place. Look how different this is from that gray one that we've been talking about. We actually have copper windings sewn in through the whole cloth bag with a tail that's coming off the bottom. This is touching the metal bottom of the float assembly. Why are we doing this? Got to maintain continuity. Put this in place. We then have another component called the manometer, which we will clamp in place. What does the manometer do? The manometer measures negative pressure within the tank. So it's going to tell you when your filters need maintenance. If it's in the green zone, the needle, you're good to go. If it's in the red zone, you better clean that filter. What is this? It looks a little different. It's an ULPA. But we can't have the configuration that we've used in all the other vacuums. Why? Because there is plastic in those ULPA filters. Can't have that in an explosion proof. All metal. Why? Maintaining continuity. Seated properly. And then, oh, this thing weighs 45 pounds. Clamp it in. All the other motors that we have used in the XA29, XA39, the clean room vacuums, the healthcare vacuums, they all contain sparking motors. Most everyone in the industry uses a motor like that. In the explosion proof, you can't have a sparking motor, so we have a sealed system right over here, along with a special switch box. Typical on-off switch that you'd find in some of the other vacuums, create a spark. This one, no spark. All right, why don't we give our explosion-proof vacuum a run for its money? Let's see what this thing's made out of, okay? I've got our explosion-proof tool, our explosion-proof handle, our explosion-proof hose. That's got the, what is this thing called? A ground wire. Runs all the way through the hose. We've got it locked into the intake. We have our unit all set up, ready to go. Let's see what we can do. What we were simulating there was picking up flour. Really nasty, small particulates. And you can see that the vacuum performs actually very well on that kind of debris. What do you say we open this thing up to see what that flour did? Where did it go? Did it pack onto the filters? Did it cake up on the bottom? Where is it? Let's take off this filter. Pretty clean. A little bit of residual, not much. Let's take off this one-to-one adapter. Here's the float mechanism. Ah, check it out. There it is. And nothing came out of the exhaust of that motor.